Okay, this is question number 10 of winter 20, paper 43. Now, examiner asking for the procedure of CT scan. A CT scan is done with X-rays. It is the general thing for CT scan that we should know. I'm making a sketch for you, and then I will write down the answer that we have to write down over there. Number one, we use X-rays. X-rays are just used because they can easily pass through the body section, different sections of the body. Then what we do is, for example, if this is an organ, we slice it down into regions. So it is not physically slicing anything, but we divide it into different regions. So we get multiple slices of that organ. So these are the discs made out of those. Then what we do is we split each slice into voxels. Okay. Every single one of them is a three-dimensional piece. You can imagine it like a cube, which can further be divided into four things. So what we do is we divide in slices. Slices are then divided into voxels. Voxels get X-rays from different directions. So we scan it in like 360-degree around the voxel. So this is how every single voxel is evaluated using X-rays. We connect them back, and those voxels they produce one slice, and then when we combine back all those slices, we can make a three-dimensional image of the structure or the organ of the body. So now I'm writing the answer. X-rays are used to investigate as X-rays can pass.
So what is it used to investigate?
Good question. What X-rays are? X-rays give you two-dimensional investigation of something. For example, if there is a broken arm, a person's broken arm, when we make X-ray, we see a two-dimensional image of the bone. And for that purpose, it is sufficient. Doctor can completely understand what has happened to the bone. But sometimes when we are investigating a human brain for tumor, then X-rays don't work very well. Two-dimensional X-rays don't work very well. We need a three-dimensional image. Not only we need the tumor, we need the exact position of the tumor as well. So in that case, two-dimensional imaging is not helpful. We need a three-dimensional imaging. So CT scan is using X-ray to produce three-dimensional imaging.
So X-rays are for 2D or 3D?
X-rays are for 2D, and CT scan is for 3D.
So CT scan uses X-ray for 2D, which is
the normal X-ray. Let me show it to you. This is an X-ray. Okay. This is a two-dimensional imaging of different organs. And for some purposes, it is sufficient. Okay.
Yes.
Now, what is CT scan? So CT scan gives you multiple. Listen, I told you that we split anything into slices. Look, these are those slices, and we can investigate every single slice. And when we combine them together, we get a three-dimensional image. Okay. So we can
Yes.
actually investigate how deep something is. See, if this doctor is looking at this thing, it is not only the two-dimensional image. He actually knows how deep inside this thing is because of the X-ray, CT scan.
Understood.
Okay. So uh, when we get it in the printed form from the doctor, doctor gives us something like this. Okay. These
Yes.
are multiple regions, multiple images of single part of body. Now, if we need any or we get any detail or sometimes if we want a three-dimensional image, then we cannot get it on paper. What doctor does, he provides you um, with a soft copy of the scan, and that what you can turn around with your mouse. You can go in or come out and investigate in with further details, and doctor can have a three-dimensional understanding of that image, that part of the body. Okay,
Understood.
good. Now, X-rays are used to investigate, as X-rays can easily pass through the human body. We split region under investigation into two-dimensional slices. Then each slice is split into three-dimensional voxel. Each voxel is defined using X-rays from multiple directions. When all voxels are connected, we get slices. When all slices are combined together, we can produce a holographic image of the region. But we can also get it in, as multiple images on paper as well, or single two-dimensional sheet as well. Okay, now
So, sir, it's like you investigate, and then you compile the investigation, and then you get a result.
Yes.
Okay.
And for this purpose, uh, X-ray receiver and X-ray producer is supposed to move 360-degree around the person. This is why this thing is round. X-ray machine is round. Why it is round? Because X-ray machine, X-ray producer and X-ray receiver, they are moving 360 degrees. Just 1 second. Okay. Now, okay, where were we? Now, here we go. Next part of the same question. This is one of the voxels. One section of the model design illustrates CT scan divided into 4 voxels. And see, dimension 1 means this is first reading. And when we read it like this, we get K, L, and M. These are the things that we don't know. We don't know the values of these things. This is first scan. This is another scan. This is another scan. This is another scan. And they all merge together to produce 42, 45, 51, and 30. Now, the first thing we need to know is what was the background reading. We're supposed to subtract the background reading from each reading, and then we divide everything with 3 to get the original number or original value of every single box over there. So here we go. We need, and examiner is asking us to calculate the values of K of K. This is one of the voxel. I was talking about voxel in the previous part. I hope you remember. So this is one of the voxel, and by making multiple readings on the top of each, we get this. And now we need to know the exact values of every single part of this voxel. So step 1, subtract 24 from each, because 24 is the background reading over here. 42 minus 28 or 24, 18, 45 minus 24, 21, 51 minus 24 should be 27, and 30 minus 24 should be 6. Now divide everything with 3. You should get 6, 7, 9, and 2.
Why 3, sir?
Because there are 3 overlap of values on the top of the background radiation. So one of them is fixed because this one produces the background radiation. So we subtract background radiation from the value, and for these 3 values, because these are 3 values on the top of each other, so we divide with 3. So KLMN. K will be 6, L will be 7, M will be 2, and N will be 9. Okay.
So if you don't get like a whole number, do you round it up?
Actually, in your case, you will always get a rounded number, because actually, this is not how simple it is. It is not done with 4 directions. It's done with multiple directions, far more than 4 directions, and it can only be done by the computer, not it won't be done manually. Okay, so these are not the exact
Yes.
numbers of anything. This is just to make you understand how these things work. A proton of wavelength this, sorry, a photon of wavelength this collides with an isolated stationary electron, as well as the incident photon wavelength this and deflected photon. The photon deflects elastically by the electron. The wavelength of the deflected photon is 544 nanometer. So the photon has lost some energy over here. Do you see the gain of wavelength? Gain of wavelength means loss of frequency. Loss of frequency means loss of energy. State what is meant by photon. Photon is a discrete packet of electromagnetic energy. It is. Photon is what? A discrete packet of electromagnetic energy. Now, draw an arrow to indicate the appropriate direction of motion of deflected electron. If this has gone this way, keeping law of conservation of momentum in mind, I think this is how electron should go. A momentum of the deflected photon. The formula for photon and diffraction comes from de Broglie's equation or de Broglie's wavelength equation, which is wavelength equals to Planck's constant divided by momentum. So momentum will be Planck constant divided by wavelength. So Planck constant is 6.63 into 10 to the power minus 34 divided by lambda will be 540 deflect 544 nanometer. So it is 544 nanometer. Okay, let's bring the calculator on. It will be 6.63 divided by 544, 0.012, 0.012 into 10 to the power 34 minus 9 minus 25. So it is 1.2 into 10 to the power minus 27 Newton meter.
So is it Newton second? That's what the
Okay, Newton second, Newton second. Examiner is giving data in 3 7 figures, so I'm providing answer with 3 7 figures as well. Now, the energy transferred to the deflected electron. So it is energy. What is the formula for energy? Energy equals to Planck constant into speed of light divided by lambda. So in this case, we can use change of lambda because we are finding change of energy. So it will be change of energy will be Planck constant 6.63 into 10 to the power minus 34 into speed of light 3 into 10 to the power 8 into 1 over 540 nanometer minus minus 1 over 544 into 10 to the power minus 9. So using a calculator, I hope we can find this. 1 divided by 540 minus 1 divided by 544. Now multiply by 3 multiply by 6.60. I get 2.71 into 10 to the power. Now minus 34 plus 8 plus 9 minus 17. So final answer will be 2.71 into 10 to the power minus 21 joule. Because there was okay, there was 10 to the power minus 4 over there. 2.708 into 10 to the power minus 4 into 10 to the power minus 17, and finally we should get 2.71 into 10 to the power minus 21 joules. Okay, moving on. Another photon of wavelength this collides with an isolated stationary electron. Explain why it is not possible for deflected photon to have a wavelength less than 544. Because less wavelength means more energy, and more energy cannot come from nothing. So less wavelength means
So is it like the conservation of energy?
yes, it is. It is exactly like that. Less wavelength means more frequency and more energy, as electron is stationary. It has no energy. So according to law of conservation, of energy of photons cannot increase. It can decrease if some of the energy goes into the electron, but it cannot uh, increase. Photons energy can decrease but cannot increase. Okay, last question of the day. Iodine this, radioactive decay constant this, state what is meant by radioactive decay constant. Now, any electron, any nucleus when it becomes unstable, let me use a big nucleus. It emits ionizing radiations this phenomenon is called radioactivity, and material is called radioactive. Okay, this material is radioactive means it is performing radioactivity, and radioactivity is phenomena of emitting alpha, beta, gamma, and radiations that can cause ionization.
So
Yes.
when you were talking about the CT scan and you talked about X-rays being emitted, how do they emit X-rays? Like, do they use a radioactive compound?
No, electrons, fast-moving electrons are stopped by a metal target. Gamma
Oh, and then
radiations.
by that
Gamma
they
radiations are
release.
obtained from radioactive materials. What we do is to produce X-rays, but we produce a beam of electrons, and when that beam is hit on an aluminum target, it loses its energy. Electrons they lose their energy and then they release X-rays.
Okay, understood.
Understood?
So
Good.
what about microwaves? How do
How to
they
produce?
how do they
How,
produce microwave?
how do we produce microwaves? I would need to check that. I think we can produce it by an alternating current passing through a coil or something like that.
That makes
Right
sense.
now, it is not my in my mind. But remember one thing: these names that we think at your level, you are thinking that radio waves, microwaves, infrared waves, they are named on the basis of their frequency and wavelength. Actually, it is not the case. They are named on the basis of how they are produced. Okay.
Oh, okay.
So that is why some radio waves have same frequencies as microwaves. Like high end radio waves have frequencies of low end microwave frequencies. There are overlapping regions,
Makes sense.
but because of doing this O levels and A levels again and again, I think it is not exactly in my mind how to produce microwaves. I think we can use a coil, but I'm not sure. I can check it out after the class.
All right. But it can't
No,
be like that elaborate because it's not expensive and all, right? Because X-rays,
exactly.
you need a machine and all.
No. Actually, X-rays are not very expensive to produce as well. But the problem is that if they are produced without control, they can cause damages to the nearby human life or person. So that's why we like the expense actually that we spend on it is to control X-rays. So we don't produce stray X-ray field or X-ray field. Okay?
Yes,
They're not
understood.
expensive to produce. They're not expensive to produce. Some instruments that produce X-rays, very high frequency X-rays, are available for very low cost. Now, activity equals to decay constant times number. So if somebody asks you to define decay constant, you can say it is activity per unit number or activity uh, per unit time. It is decay per unit time. Now, some water becomes contaminated with iodine 131. The activity of the iodine is 1 kg of water is this becquerel. Determine the number of atoms in 1 kg of water.
So can we
No,
think of N as moles?
no, N is not moles. N is number of particles. It will be moles if you divide with Avogadro's number.
Oh, okay.
As I told you, the formula of activity is lambda n, and we know the lambda is given as was lambda given? Yes. Iodine lambda is 9.9 into 10 to the power minus 7. 9.9 into 10 to the power minus 7 n. So n equals to 560 divided by 9.9 into 10 to the power minus 7. 560 divided by 9.9. So it is 5.7 into 10 to the power. What was 10 to the power? Okay, 10 to the power can be calculated away. 10 to the power 8. 5.7 into 10 to the power 8 particles. Now, regulations require that the activity of iodine of the water is less than 170 pascals. Calculate the time in decay in days for the activity of the contaminated water reduced to this pascal. Now, the formula is A equals to A naught E minus lambda T. So we want it to be 170. Right now it is 560, 40, 560. It is 560 e power minus 9.9 into 10 to the power minus 7 into t. So what do we do?
As it E as in like the exponent E?
Yes, it is exactly like that.
Okay.
So you can think of this as minus 9.9 into 10 to the power minus 7t equals to ln of 170 minus ln of 560. I have applied ln on both sides. So t will be 170 ln minus 560 ln equals to this divide by 9.9. So we have 0.12 into 10 to the power 7 seconds. But he asked for time in days. So we have to divide this time with 86,400. That is number of seconds in a day. Or you can just simply divide with 24 and then 60 and then 68. You get the same answer.
14 days.
Let me check. $13.9 days. Okay, 14 days. Okay,
Yes.
understood?
Yes, sir. Understood.
So that is the end of the paper.